So in this video, we're going to look at equations that have more variables, there's distribution, and maybe even take a look at some special cases. So here we have a variable on both sides. So we have a variable on both sides. We want to keep in mind, we want to get the variables on one side and the numbers on the other. It doesn't matter which side is which, and you might have a preference. But since I wrote variables on the left, I'm going to move this variable that's on the right to the left by subtracting it. So I get negative 3p minus 14 equals 4. Now I'm trying to get the numbers to the other side, so I'm going to add 14 here, and I'm left with negative 3p equals 18. And then I'm going to finish the problem by dividing by negative 3. So p equals negative 6. And I look at this next one. I could divide by negative 4 first. That's an option. The other thing that I could do is to multiply both of these things by negative 4. If we kind of think of this as like 63, right? You would multiply both the 60 and the 3 by the 4. So we're going to multiply both those things because there's two terms by the negative 4. So when I do that, I'm left with 24x plus 12 equals 12. And then I'm going to subtract 12 from both sides. And I get 0 equals 24x. Divide by 24. So x equals 0. Now that seems kind of suspicious, but if I go back and check it, I think it works out. 12 must equal negative 4. Well, negative 6 times 0, well, that's just 0. And 0 minus 3, 12 equals negative 4 times negative 3. Yeah, that's true. 12 equals 12. So that is the correct answer. I'm going to look at this next one. I'm going to multiply both of these by 6 and see what happens. So negative 18 minus 6k equals 6 plus 18k. And again, I'm going to choose which side I want to get my variables on because I notice that there's variables on both sides. So I'm going to add 6k to get my variables on the right. Negative 18 equals 6 plus 24k. I'm going to subtract 6 to get my numbers on the left. Negative 24 equals 24k. I'm going to divide by 24. Negative 24 divided by 24. K must be negative 1. So I usually do suggest that we distribute first and then look to see that you combine like terms, but that doesn't mean that there's not more than one way to solve these problems. So I'm distributing by multiplying both those by negative 8. And I'm going to get the numbers over here first, it looks like. So I have 3n plus 43 equals negative 40n. And then I'm going to move this 3n over here because I have variables on the right. And again, I'm going to divide 43 by negative 43, get the same answer as the last one. Negative 1 equals n. Now, that's it for these problems, but I want to show you one more special example. So let's say we had the problem 2 multiplied by 3x minus 1 minus 5x equals x plus 7. So when I start working on this problem, I might distribute first. So I have 6x minus 2, and I'm just going to tack that on because it's not part of the parentheses, equals x plus 7. There are some things that I can combine here. So I can combine on the left-hand side my 6 and my negative 5x. So I have x, just 1x, minus 2 equals x plus 7. So now if I notice I have variables on both sides and I might want to get them on one side. So what if I subtract this x or this 1x here? Well, that's kind of weird because when I subtract x, I'm just left with negative 2 over here. And on the other side, I'm left with 7. And that doesn't make any sense, that negative 2 would equal 7. So what that means is that this doesn't make any sense. So there's actually no solution to this problem. There's no value of x that will actually make this equation true. So when you notice that you get a false statement at the end, that means that there's no answer to the problem. Kind of similar, but let's say we had the problem 3x plus 5 equals 3x plus 5. And let's say we kind of went about our process and we said, oh, we're going to subtract 3x, get the variables together. Well, you get this true statement, 5 equals 5. And what that means is that x could be anything, or x equals all real numbers. There's no limit to what x is because it could be anything and it'll always be true. Now, this equation is pretty obvious because it's the same thing on the left and the same thing on the right to begin with. But some might have an equation that looks a little bit different on both sides, in which case you'd kind of have to simplify it first before that might be visible. So if I looked at this equation, kind of do that out, I get 2x minus 10 plus 8 on the left equals 2x minus 2. And then if I combine those, I get 2x minus 2 equals 2x minus 2. So now I could kind of see, okay, well, if I look at this, this is a true statement, or if I subtract 2x, I really get negative 2 equals negative 2. So x is all real numbers.